What's up everybody and welcome to a new video. And in this video we're going to go over my notes for control flow in Python. And here I first have a definition, namely I define control flow as controlling which parts of the code should be executed and how often they should be executed. And therefore you can use if statements or looping. So let's start here with if statements. And here again, I have a definition. This time it's for condition, and I define it as an expression that is evaluated down to true or false. Then the next note here states, with an if statement, you check if a condition is true or if multiple conditions are true. And if that's the case, then some code is executed. Otherwise, it is not executed. So now let's look at an example for that. So therefore, let's create here a variable called number, and let's set that equal to 4. And now let's use an if statement here. So we're going to say if, and now we're going to check if that number is bigger than 0. So here then we say number bigger than 0, and then a colon. And then here on the next line, we simply use here a print statement and say, let's simply here print if. So now if I run this, then you can see that this if here was printed. So this print statement here was executed, and that's because here this condition was true. So this is how you can use one condition, but you can also use multiple conditions. So here then, for example, let's say that we also want to check here if the number is an even number. So therefore then we say here and then number, and then here the modulo operator, and then 2. So if we divide our number by 2, and then if the remainder is equal to 0, then the number is an even number. So now let's again run this cell. And here again, this if is printed. So this print statement here was executed because now these conditions here were true. However, if I now set this number here to a 5, then no if here is printed. So this print statement was not executed because these conditions here were not true. So that is the basic use of an if statement. Then the next note is about some optional components that are available. And those are the else statement and the elif statement. So let's start here with the else statement. Namely, here in our code example, nothing gets executed because this condition here was not true. However, if I now say here else and then print else, then if I run it like this, then you can see that it now prints here else. So as you can see, this else statement here gets executed whenever the if statement here is not true. Okay, so that's the else statement. Next, we have then the elif statement. So to show that, let's say here in our code example, here in this place, we don't just want to print else, but instead we want to have another if statement. So here now let's simply check if the number is bigger than 0 and if it is an uneven number. So therefore, let's simply copy this here and then paste it and then make this here a 1. And then here we're going to say print else if. So now if I run it like this, then it prints here else if. And this else if statement here can be done more succinctly with this elif statement. So therefore, let's simply unindent that here and then here delete this else. And then here we can say elif. And then let's also print here elif. So let's make it like this. And now if I run it like this, then you can see now here that it prints elif. And here, as you can see here on this note, you can also have multiple elif statements. So now let's add another one. So let's say here elif. And now here, let's simply check if the number is smaller than 0. So we're going to say number smaller than 0. And in that case, then we're going to print second elif. And then here for this first one, we're going to print first elif. So now if I run it like this, then it now prints here first elif. However, if I make this now a -5, then it prints here second elif. So the second elif statement gets executed. However, now if I make this here a 0, then again, nothing gets executed because none of these conditions are true. So in that case, then we can here then say again else, and then simply print else. And then again, it prints else because none of these other conditions here were true. Okay, so those are the optional components that are available. So now let's go over the side note here, which is about something called truthiness. Namely, besides the Boolean values true and false, other values are interpreted as being true or false as well. And to show that, I've prepared here this code snippet. So if I run this, then you can see all the values that are considered falsy and all the values that are considered truthy. So for example, an integer 0 is considered falsy, a float 0, a complex number that is 0, and then here this value is here this empty string. So an empty string is also considered falsy. The none value is considered falsy, and then here empty lists, tuples, dictionaries, and sets are also all considered falsy. And then here are the truthy values. So any integer that is not 0 is truthy, any float that is not 0, any complex number that is not 0, any string that is not empty. So for example, here we only have this space in the string, so it's also considered truthy. And then here any list, tuple, dictionary, or set that contains a value is also considered truthy. Okay, so that is truthiness. And with that, now we've covered here all my notes with respect to if statements. So now let's go over my notes for looping. And the purpose of looping is to repeatedly do something over and over. And there are two types. There are for loops and there are while loops. So let's start here with the for loop. Namely, with that, you repeatedly do something over and over for every element in an iterable. And iterables can be, for example, data structures, strings, or the built-in function range. So now let's first look at some examples with data structures. So therefore, I've prepared here these data structures. So the first one here is simply a list which contains the numbers 1, 2, and 3. And now let's say we want to loop over this list and then print out the squares of those numbers. So therefore then you can say here for number in data structure, and then we're going to print the number squared. So now if I run this, then we get here the numbers 1, 4, and 9. Then here, if I use here, for example, this tuple, and then run it again, then we get the numbers 16, 25, and 36. And then here, if I use here the set, then we get the numbers 64, 81, and 49. So that's how we can use over those data structures. And you can also do the same thing for dictionaries. So here I've prepared a dictionary. So here again, let's say we want to print out the squares of those numbers here. So therefore then we would say for key in dictionary, and then we want to get the respective number. So we're going to say number equals dictionary and then brackets key, and then we want to print out the squared. So we're going to say number squared, and now if I run this, then we get here the 1, 4, and 9. So this is how we can loop over data structures. And here I also have a side note, namely this states that even though dictionaries are technically unordered, they actually preserve the insertion order, i.e. they preserve how the order in which their elements were initialized or added. And this doesn't necessarily apply to sets. So to show that, I've prepared here another set. So here I transform the string into a set and then loop over all the elements and then simply print them out. And now if I run this, then you can see that we get here the order L-H-O-E, even though here the order is H-E-L-O. And also earlier in this example here, we had the number 7, 8, 9. However, the order in which those squares were represented was here. First we have the square of 8, then 9, and then here 7. So the insertion order was not preserved. However, for this dictionary here, the order was 1, 2, and 3. And here we then got the squares 1, 4, and 9. So here the order was preserved. And now, if I, for example, here restart this notebook and then run those sets again, then you can see for the set, this order stays the same. So here we still have the square of 8, then 9, and 7. Then here for the dictionary, again, the order stays the same. So we have here 1, 4, 9. And then however, for the string, if I run this again, then you can see now the order here has changed. Okay, so that is this side note here that I wanted to cover with respect to data structures. So now let's look at an example for looping over a string. And therefore, let's simply create here a variable called word. And let's make this a string which says hello. And then now let's loop over all the characters of this string. So we're going to say for character in word, and then we're going to print that character. So now if I run it, then you can see that those individual characters here are printed out. So that's a for loop over a string. And now let's look at this example here for the built-in range function. So therefore then we can simply say for I in range 5, for example, and then let's simply print out I. And then here we get those numbers 0 to 4. Okay, so those are some examples for showing how a for loop works. So now let's go over these side notes here. And the first one states that, as seen in the examples, you can name the for loop variable however you want. So for example, in this for loop here, we call it I. In this for loop, we call it character. Then here element, here key, and here number. So you can really name it however you want. So that's the first side note. The second one then states that when running a for loop, there's actually a variable created. So for example, the last for loop that we ran was this one, where we use here variable I. And then here, if I print out I, then you can see that it's actually 4. And that's because in the last iteration of this for loop, I was set to 4. So that's the second side note. And then the last one is that if you're not using the for loop variable within the for loop, then you can indicate that by using an underscore. So for example, in this for loop, let's say that we don't print out here I, but instead we print out hello world. So we are not actually using here this I in our for loop. So therefore then we can indicate that by here simply using an underscore. So that is then this third side note, and with that we've covered all the side notes, and with that we've covered all my notes that I wanted to cover with respect to for loops. So now let's go over my notes for while loops. Namely, you can use them when you want to repeatedly do something over and over while a certain condition is true, i.e. do it over and over until the condition is not true anymore. And there are different approaches how you can do that. And the first one is when using a condition. So to show that, I've prepared here this for loop. So here I'm saying for I in range 3 and then print out I. So then we get here 0, 1, 2. And we can also achieve the same thing with a while loop. So therefore we create here this variable n and set that to equal to 0. And then we say while n is smaller than 3. Then we want to print n. And then after that we increase n by 1. So we're going to say n plus equals 1. And now if I run this, then you can see that we also get, or that we also print out here 0, 1, 2. So that's the first way how we can use a while loop. Then the next approach for using a while loop is to use a Boolean flag. And to show that, let me here copy this cell. And then here what we're going to do is we create another variable. And here we're going to say process running. And we're going to set this variable equal to true. And then here in this while loop, what you're going to say is while process is running, then we print our n, then we increase our n by 1. And then we also need to make sure that this while loop stops again. So therefore we have to set this process running variable equal to false. And we're going to do that when n is bigger or equal to 3. So here then we simply say if n is bigger or equal to 3, then we're going to set this process variable, a process running variable equal to false. So now if I run it like this, then you can see it again prints out 0, 1, and 2. So that's the second way how we can use a while loop. And then the last approach is to use the break statement. And we talk about the break statement in a moment in more detail here. However, let me now just quickly show how this works. And therefore, let me here again simply copy this cell. And then here, instead of using this process running variable, what we're going to say is here simply while true. And then to stop this while loop from running, here we're simply going to say break. So we're going to use this break keyword. And now if I run it like this, then you can see it again prints out 0, 1, 2. So those are the 3 approaches that you can use for creating a while loop. And then here, the next note mentions something that you need to be careful about. Namely, if the stopping condition of the while loop is never triggered, then the loop will run forever. i.e. it will enter an infinite loop. So to show that, let's look again here at this first example of this while loop where we used here the condition. So here in this case, let's say that we forget to increase our n here. So if I run the while loop like this, then as you can see, it will enter then this infinite loop. So let's stop this. Then here, the next example was this while loop where we used here the Boolean flag. So here in this case, let's for example say that this if statement here is never triggered. So for example, if we say here, if n is smaller than 0, then in that case, this is never triggered. So we never set this process running variable equal to false. So if we run it like this, then again, we enter here this infinite loop. So let's again stop it. And then here in the last example, where we used here this break statement. Here again, if this if statement is never triggered, then we never reach here this break statement. So for example, if we also say here, if n is smaller than 0, and then run it like this, then we enter this infinite loop. So that is something that you need to be careful about. Namely, you have to make sure that the stopping condition of the while loop is triggered. And here I also have a side note. Namely, this states that technically it is also possible to enter an infinite loop with a for loop. So to show that, let me create here a variable called list. And this is going to be a list which contains a 1. And now let's loop over this list. So we're going to say for number in list. And then we're going to simply print out the respective list. And then what we're also going to do is to append another element to that list. So we're going to say list.append. And we're simply going to append number plus 1. So now if I run it like this, then you can see that we again enter here this infinite loop. So let me again here stop that. So that is the side note that I wanted to cover here. And with that now we've covered here all the nodes with respect to while loops. And with that then we've covered all my nodes with respect to the different two different types of loops that are available. So now let's go over these side notes here. And the first one is about the continue statement. And what that does is it simply skips to the next iteration of the loop. So let me show that for a for loop. So therefore here we're going to say for I in range 10. And then let's simply print out I again. So if you run it like this, then all these numbers here are printed out. So from 0 to 9. But now let's say that we only want to print out the uneven numbers. So we want to skip here this print statement when the number is an even number. So therefore then here we say if I and then the modulo operator 2. So if the remainder of that division is then 0, then what we want to do is we want to continue to the next iteration of the for loop. So now if I run it like this, then you can see that only here the uneven numbers are printed out and the even numbers have been skipped. And the same thing also works for a while loop. So here I've prepared such a while loop where we do here the same thing. So if I run it like this, then you can see it also prints out only the uneven numbers. So that is the continue statement. Then next is the break statement. And as the name implies, this breaks, i.e. stops the loop. So let me again show you that by using a for loop. So here I'm going to say again for I in range 10. And then we're again going to print out the I. So now if I run it like this, then we have here again the numbers 0 to 9. And now let's say that we want to stop this loop when I is bigger than 5. So we don't want to print out those last 4 numbers here. So we can do that by saying here, if I is bigger than 5, then we want to break. So now if I run it like this, then you can see that we're only printing out the numbers 0 to 5. And here again, you can also use that or do that with a for loop. So here I've prepared such a for loop. And now if I run this, you can see that we only are also here printing out the numbers 0 to 5. So this is how the break statement works. And then lastly, we have the else clause, and this is optional, and it gets executed when the loop fully runs through, i.e. when no break occurs. So to demonstrate that, let me again use here a for loop. So I'm going to say for I in range 5, and then I want to print I. And now I want to use here this else clause. So I'm going to say else, and then here let's simply print else. So now if I run it like this, then you can see that all the numbers here of this for loop get printed out. So from 0 to 4, and then also here this else gets printed. So this else clause here was executed because this for loop here fully ran through. But now, however, let's break this for loop. So we're going to say here if I is bigger than 2, then we want to break. So now if I run it like this, then you can see that only here the numbers up until 2 are printed, and this else here is not printed. So in this case here now, because we broke here this for loop, this else clause was not executed. And the same thing also applies to for loops, to while loops. So here I have prepared such a while loop. So if I run it like this, then you can see again the numbers are printed out and also the else. But now let's again break this while loop. So we're going to say if I is bigger than 2, then we want to break. And here again, only those numbers now are printed and not here this else. Okay, so that is the else clause. And with that, now we've covered here all these side notes. And with that, then we've covered all my notes with respect to looping. So with that, then we've covered also all the notes with respect to control flow. So we've reached the end of this video. And then in the next video, we're going to go over my notes for functions in Python. So thanks for watching, and hopefully I will see you in the next video.